Hello everyone, I hope all of you are doing good. So today I am here with triangles and its properties class 7 maths, and in this video we are definitely going to talk about triangles. In fact, we are going to talk a bit more about their properties. Now this is going to be a very important lesson because as you go to your higher classes, triangles will always be very important. So I am Roshni from Learner Hub, the free learning platform where you get to study everything about maths and science absolutely for free at learnerhub.com, and we ensure that we upload new video every day on this channel. So stay tuned and be with us. What do you think are we going to study in triangles? Now, I'm pretty sure by now each one of you know what a triangle is. It's a polygon with 3 sides. And where do we see triangles? In so many things around us. In fact, if you start with that shape of the sandwich, which is a triangle, or if you look at a pyramid where also you can visualize a triangle. In fact, I would want you to look around yourself and see where all can you identify a triangle. So in this video, our agenda would be to study more about the properties of triangles. So are we all ready? Let's get started. So what exactly is a triangle? The name itself says triangle. Tri means 3. So basically it is something with it is a geometrical shape with 3 angles. So it is basically a polygon with 3 sides. So 3 sides, therefore 3 angles. What is a polygon? A polygon is a figure which is closed, which is formed only by line segments. So here you can say this is a closed polygon, that is you have line segments forming a closed structure. And how many sides do you have? You have 3 sides. Now when you look at this triangle on the picture, this is normally represented in this fashion. Triangle ABC. So we do not write the word triangle, instead we just put this symbol of a small triangle and then we write ABC. Now, the basic elements of triangles are sides, angles and vertices. So when we say sides, so what are the sides for this triangle? So AB, BC and AC. These are the 3 sides of the triangle, AB, BC and AC. Next are the vertices. So what are vertices? Vertices are those points where the sides meet. For example, point A. So A is a vertex. So at A, BA and CA, they both meet. Similarly at B, AB and CB, they meet. Similarly, AC and BC, they meet at point C. Therefore, points A, B and C are the vertices of the triangle. And then the third element, that is angle. And which are the angles? Angles tell us the orientation between the sides. For example, this angle A, which can also be named as angle BAC. This shows the orientation between AB and AC. Similarly, this angle B shows the orientation between AB and BC. So this can be written as angle ABC. Similarly, this angle, which can be written as angle ACB, this shows the orientation between AC and BC. So all in all, there are 6 elements which define a triangle. What are those 6 elements? 3. So all in all, there are some 9 elements which determine or which specifies a triangle. 3 sides, 3 vertices and 3 angles. Now, a couple of other things are, for this angle BAC, let's say this is BAC. So for this particular angle, which is the opposite side? So the side located opposite to it. That means that side which doesn't participate in the formation of this angle. So for angle BAC, if you take example of BAC, for this angle, the opposite side would be BC. Similarly, if you talk about angle ACB, which one would be the opposite side? So which is the side which is located to angle ACB? It is this side, that is AB. Similarly, if you take example of any side, let's say if you talk about side AC. So for AC, this is the side AC, which is the opposite angle. So the opposite angle would be this angle. So for AC, the opposite angle would be angle ABC. Similarly, for AB, which one would be the opposite angle? This is AB, so the opposite angle would be angle C. So for AB, opposite angle would be angle ACB. So these are some of the very common properties or the basics of a triangle. Now, there are many different types of triangles. In fact, the types of triangles also varies depending on what is the basis for categorizing triangles. Now, first of all, let's talk about the types of triangle based on the sides. So, there are three types of triangles. The first one is scalene triangle, which is that type of triangle where all the sides are unequal. That means when you measure the sides, all of them are of unequal length. For example, you have this triangle ABC. So in a scalene triangle, the length of AB is not equal to the length of BC, which is again not equal to the length of AC. So this defines a scalene triangle. The next type of triangle is an isosceles triangle. Now in isosceles triangle, two sides are equal. So a type of triangle where if this is A, B and C, so in this type of triangle, AB is equal to AC. That means this side and this side are equal in length. Now since these two sides are equal in length, these angles are also equal in length. These are called the base angles. So angle B is equal to angle C, and angle B and angle C are called the base angles, because they are like located on the base. This is the base side and these two angles are located on the base side. So they are called base angles. So that is isosceles triangle. Can you guess what would be the third type of triangle? See, first type of triangle was scalene, where all sides were unequal. Second type was isosceles, where two sides are equal. Third is equilateral, where all sides are equal. The word equi comes from equal. So all sides equal, all angles equal. So something like this. So here if you have a triangle ABC, so here in this case AB is equal to AC is equal to BC. So in this case AB equal to AC equal to BC. All sides are equal, all angles are also equal. That is angle A is equal to angle B is equal to angle C. So based on the length of the sides, whether the sides are equal or unequal, triangles are divided into scalene, isosceles and equilateral triangles. Now let us look at the types of triangles based on the angles, based on whether how the angles are, what is their value. So the first type of triangle would be acute-angled triangle. That means all angles in this triangle will be less than 90 degrees. So all angles are acute angles. So in this figure, you can see that each of this angle is less than 90 degree. So this is an acute-angled triangle. The next type would be right-angled triangle. So in a right-angled triangle, one angle is 90 degree. As you can see here, this angle is 90 degree and other two angles are definitely acute angles. Now, do you think that you can have a triangle where two angles are 90 degree? No, you can't. If you want, you can just try it out, because a triangle will have only three sides. It cannot have more than three sides. So in order to have 190 degree, this is how the arrangement should be. Now, if you want one more 90 degree, that means there has to be the third side should be perpendicular either to this, or the third side has to be perpendicular to this. Now, in both the cases, do you think that you will be able to form a triangle? No. Even though you have three sides, but you do not form a closed polygon. You do not form a closed bounded figure. So therefore, this is not a triangle. So you cannot have a triangle with more than 190 degree. So whenever you have a triangle where one angle is equal to 90 degree, that is called a right-angled triangle. And the third type of triangle would be obtuse-angled triangle, where one angle is greater than 90 degree. Something like this. So when you look at this angle is greater than 90 degree. However, the other two angles are again acute angles. That's because once you have one angle greater than 90 degree, the other angles will be smaller. Again, in a similar way, you can see it for yourself that you cannot have a triangle where more than one angle is an obtuse angle. So now let us talk about something more interesting. Let's say that it's your birthday, and this time for your birthday your mom ordered your birthday cake, which is a chocolate cake and which is triangular in shape, something like this. So a triangular chocolate cake for your birthday this time. Now your mom gave you a task that you have to divide this cake into 6 equal pieces, 5 for your friends who have been invited for your birthday and 1 for yourself. So you have to divide this cake into 5 equal slices. So how do you divide this cake? So 6 equal slices you want. So let's say that what you do is you take this cake and you divide it somewhat like this. So how many pieces you have? 1, 2, 3, 4, 5 and 6. So this is how you divide it into 6 equal pieces. Now do you know what are these lines? What are these lines which divide this triangle into 6 equal triangles? Because you see each piece is also a triangle. If you look at piece number 2, it is a triangle like this. If you look at piece number 1, that is again a triangle like this. Piece number 3 is a triangle like this. Similarly, piece number 4 is a triangle like this, and so on. So each of the pieces of cake is also a triangle. So do you know what are these lines called which divide a triangle into 6 equal triangles again? So these lines are nothing but medians. So they are called medians, and we are going to discuss about medians here. So what exactly is a median? It is a line segment joining a vertex of a triangle to the midpoint of opposite side. Let's say this is a triangle ABC. So any line which joins a vertex, let's say the vertex A. So the line joining vertex A and the midpoint of the opposite side. Which would be the opposite side for vertex A? Definitely this side. So BC is the opposite side for vertex A. Midpoint of BC is, let's say, 8. So any line segment that joins A with D is called a median. And what does a median do? This median, once you draw this line segment or once you draw this median, it actually divides the triangle into 2 equal triangles. So earlier you just had one triangle ABC. Right, so initially you had one triangle, that is triangle ABC. Now with the help of one median, you have been able to divide this triangle into 2 equal triangles, that is angle ADB and triangle ADC. Now when I say 2 equal triangles, what I mean is the area of these 2 triangles are equal. That is, this area is equal to this area. So this entire area occupied by triangle ADB is equal to this total area occupied by triangle ADC. Now looking at this concept of median, can you tell me maximum how many medians can be present in a triangle? Now how many vertices do we have in a triangle? We have 3 vertices. We cannot have more than 3 vertices in a triangle. Now every median has to start from a vertex. Right? So for example, one median can be drawn from point A. Similarly, one median can be drawn from the vertex B. Another median can be drawn from vertex C. Therefore, a total of 3 medians can be drawn in a triangle, as you can see here. So AD, let's call this E, let's call this F. Therefore, we can say that AD, BE and CF, these are the medians for this triangle. So these are different medians for the different vertices. Now once you draw all the 3 medians, you actually end up dividing the triangle ABC into 6 triangles of equal area, because the area of triangle A, if we call this point as O, then we find that the area of triangle AOE, that is this triangle, is equal to the area of this triangle, which is equal to the area of this triangle, and so on. So all the 6 triangles are of equal areas. So now you understand how the cake was divided. So in order to divide the triangular cake, 3 medians were drawn, and those 3 medians ensured that the triangular cake was divided into 6 triangular pieces, each of equal area. Now many times People feel that median and perpendicular bisector, they are the same thing. But actually these are very much different from each other. Now even before I talk about how they are different, let us look at what exactly is a perpendicular bisector. So when we say perpendicular bisector, perpendicular means a line which is perpendicular to a particular line. That means a line which makes an angle of 90 degree on a particular line. So that is perpendicular. Fine. Bisector means a line which bisects another line. That means it bisects or divides another line into two equal parts. Now if I say perpendicular bisector of a side of this triangle, let us name this triangle. Let us say you have this triangle ABC, and let us say I want to draw the perpendicular bisector of side BC. So what would be the perpendicular bisector of BC? It would be a line which divides BC, which bisects BC into two equal parts. So let's say this is the midpoint of BC, and also that line should be perpendicular to BC. So basically somewhat like this. So if we draw a line like this which is perpendicular to BC and which also divides BC into two equal halves, that is called a perpendicular bisector. And by now we know what is median. Median is that line which joins this midpoint of BC to the vertex A. So that would be median. Now what happens is that in certain triangles, for example this triangle, which is actually an exception. So in some exceptional triangles, what happens is the median and the perpendicular bisector, they coincide. Now this happens as a special case of a triangle where all the sides are equal. What type of triangle is that? Yes, equilateral triangle. So in an equilateral triangle, it can happen that the perpendicular bisector and the median, they coincide. So that is basically they both are represented by the same line. But that doesn't mean that a perpendicular bisector and the median, they will always coincide. Now let me give you an example of a triangle like this. So what kind of triangle is this? This is an obtuse-angled triangle, right? Because we have an obtuse angle here. Now for this triangle, if I ask you to draw the perpendicular bisector for side BC, so how would the perpendicular bisector be for side BC? It has to be a line which bisects BC, right? And it should also be perpendicular to BC. So something of this sort, let's say this is the midpoint of BC, let's call this point as O. So perpendicular bisector would be perpendicular, that is it will be 90 degrees on BC, and also it divides BC into two equal halves, BO and OC. Clear? So this is the perpendicular bisector. Now do you think that the same line, that is this line, is also going to be the median? Definitely not, because median is that line which joins the midpoint of BC to the vertex, that is to point A. So basically the median for the same triangle would be somewhat like this. So basically this is your median. So do you think that in this triangle the median and the perpendicular bisector in any way coincided? No, they both are completely different lines. So they are completely different from each other. So this is one example where we see that the perpendicular bisector and median, these are two different lines, these are two different things. You take another example. Let us talk about this triangle, which is a right angled triangle. So you have a 90 degree here. Now if I ask you to draw a perpendicular bisector on BC, that would be somewhat like this. Again, a line which is perpendicular on BC and which also divides or bisects BC. That is, it is drawn at the midpoint of BC. Now, do you think this line is going to be the median for the same triangle? Definitely not. Again, when you take the same triangle and you draw the median, median is that line which is going to join the vertex to the midpoint. So median is a separate line. So it is just in some special case where the perpendicular bisector and the median coincide. But otherwise these are two different concepts, these are two different lines. They are completely different things. They are not the same thing, right? So that's about median. So here we are learning about median, and I want you to know how different median is from something like a perpendicular bisector. Okay, now we are going to introduce another attribute or another parameter that defines a property of a triangle, and that is altitude. Like how we spoke about median. Similarly, this is another concept of altitude. Now, what do we mean by altitude of a triangle? So altitude is nothing but the height of a triangle. So in literal, if you look at the literal meaning, altitude is nothing but height. Have you ever measured your height? Have you ever checked how tall you are? How do you do that? So maybe somewhat like this. This is how you measure your height, to see how tall are you. Similarly, if I ask you to measure the height of a triangle, how would you do that? So just try to think of the same setup, just that you are being replaced with the triangle. So which part of the triangle gives you the height of the triangle? So looking at this picture, can you visualize what gives the height of the triangle? So basically, when you look at this triangle, do you think that the length of any of the sides would be able to give the height? No. So what is the height of the triangle? So when you measure the height of the triangle like this height defines the height of the triangle. And this height is determined by a line which is drawn perpendicular on a side of the triangle. Right? So this gives the height of a triangle. Now the interesting part here is that one triangle doesn't have just one altitude. That's because when you look at this triangle, not all the sides are equal, right? So many triangles have unequal sides. So when you look at the triangle from different perspectives, you feel that the height of the triangle also varies. Sounds confusing? Let's have a detailed look. So basically here on the screen, you see two different images. Now basically we are seeing the same triangle. So in both the images you have the same triangle. It is just that you are seeing it from two different perspectives. So in the first case, you see that the height is smaller than in the second case. But we are talking about the same triangle. It is just that we have kind of rotated the triangle. So when you, let's call this triangle as ABC. Let's name this triangle as ABC. So when you look at its height is, and when you look at the second scenario where we have exactly the same triangle, even though you might feel that no, it seems to be a different one, but actually it is the same triangle. It is just that we have rotated it. We have rotated it in such a way that now we have point C here, we have point A here, and point B is here. So basically we have just rotated it in the anti-clockwise direction, and that's how it has become like this. Now when we try to measure the height of the triangle, keeping it in this pattern, then what do we see? The height has increased. So even though we are talking about the same triangle, we see that when we look at it from two different perspectives, we get two different heights or two different altitudes. So how do we define altitude of a triangle? So altitude is a line segment which is drawn from a vertex perpendicular to its opposite side. So that is how we define altitude of a triangle. What that actually means, let's say that you have a vertex A. So from A, you draw a line segment which is going to be perpendicular to the opposite side. So for vertex A, the opposite side is BC. And this is the line, let's call this AD. So AD is perpendicular to BC. So therefore AD defines the altitude. Similarly, in this case, we are actually measuring the altitude from vertex C, because this is how the triangle is positioned right now. So from vertex C, you draw a perpendicular on the opposite side, that is AB. So let's call this D. So in this case, CD is perpendicular on AB. Therefore, in this case, CD is the altitude of the triangle. Now, you might ask that, okay, so if we have one triangle, so how many altitudes are possible? Now again, altitudes are line segments which are drawn from vertex. So how many vertices does a triangle have? A triangle has three vertices. That means we can draw three such line segments perpendicular to their respective opposite sides. Therefore, a total of three altitudes are possible for a particular triangle. So even though altitude of a triangle is just like height of a triangle, the way we talk about height of a person, but in case of triangles, since we have three different sides, therefore a triangle can have three different heights based on from which vertex are we trying to measure the height of that triangle. So this is the concept of altitude of a triangle. So I hope the concept is clear. Now try to compare this altitude with the median that we had learnt before. So as I was telling just now, any triangle can have three altitudes. So let us look at this triangle ABC. So the altitude from A would be this perpendicular drawn on BC. Similarly, the altitude from B would be the perpendicular drawn on AC. Similarly, the altitude from C would be the perpendicular drawn on AB. So a triangle can have three altitudes. Let us have a quick comparison of altitude versus median of different triangles. So on the screen we have an obtuse-angled triangle, a right-angled triangle and an acute triangle. And in each of these we will see that how would the altitude be for each of them and how would the median be for each of them. And that's how we will differentiate between the two. So let us first draw altitudes on side BC of each of these triangles. Let us name this triangle also. This is ABC. Now, so for all the three triangles, we are going to draw the altitudes on side BC. That means we are going to draw altitude from the vertex A for each of them. So for this one, which is the simpler one, we draw a perpendicular from A on the opposite side, that is BC. So let's call this point as D. So AD is the altitude. Perfect. Next, for this right angled triangle. So here at this case, we have to draw a line from A perpendicular to the opposite side, that is BC. So the moment we draw a perpendicular line, we see that it actually coincides with the line AB. So basically one of the sides of the triangle has become the altitude. So AB, which is one of the side of this right angle triangle, is the altitude for the triangle. Perfect. Now let us look at the third one, that is the obtuse-angled. So here we have to draw a line from point A such that the line should be perpendicular on BC. So see, in this case you will see that the observation is quite different. So here you see that this is the line which is drawn from point A, which is perpendicular on extended BC. Basically, you can never draw a line from A which lies inside the triangle and which is also perpendicular to BC. That is not possible at all. So what we do is we extend this BC in this direction and then we draw this perpendicular. So this defines the altitude of this triangle. So in this case, what do we see? We see that the altitude for an obtuse-angled triangle lies outside the triangle. So here we can say that altitude lies outside the triangle. In this case, what did we observe? In this case, we saw that altitude is one of its sides. So one of the sides of the triangle itself is the altitude. So this is the altitude for all these different triangles. Now let us try to draw the medians. Now when we start drawing the medians, we see that for this obtuse-angled triangle, how do we draw median? A line from the vertex A, but now this line should connect to the midpoint of the opposite side, and the midpoint is this point. So basically this is the median. So this line is the median, whereas this line is the altitude. So altitudes and medians, they are again two different concepts. Similarly, when you talk about the right angle triangle, here again you would draw a line from here, but this has to connect to the midpoint of the opposite side. So this is the median and this is the altitude. And similarly, for the acute-angled triangle, when you try to draw the median here, now in case this is a special case of acute-angled triangle where all the sides are equal, only in that case you would see that the median and the altitude would coincide with each other. So what do we understand from this? We understand that median is one concept which tells us how can we divide a triangle into equal triangles or multiple triangles of equal areas. So median helps us to do that. Median divides a triangle into smaller triangles of equal areas. When we talk about altitude, it gives us the height of a triangle. Now height of a triangle from different perspectives are different. So we can draw 3 medians in a triangle, we can draw 3 altitudes in a triangle.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.